I will post it online. Have any particular questions? Do y'all want to look at the free response, or are you okay looking at it on the website? Do you want to work through it? Excuse me, here. Work through the free response here in this time. It'll take about 5-10 minutes. All right, so like I said, your free response is going to look a lot like this, especially this first problem. I just want you to know how to do the problem where something goes up and comes back down again, because we're going to have to know how to do that cold for the next chapter, because we're going to expand on that a little bit. I always like to draw a picture. So I draw my object, in this case baseball. It goes up and comes back down again. I like to remind myself that the velocity at the top is equal to 0. I write the initial velocity down here is 50 meters per second. And I want to know what is the total time in the air. So the first thing I want to do is figure out what is t top, because I know what v top is. I know that the velocity at the top is equal to 0. I know that the acceleration is minus 10, and so to find t top, I just say that v is equal to v naught plus a times t, and then I solve that for t. And remember, if this is v top, this is t top. Oh, the pen in this room doesn't work very well, unfortunately. We'll deal with it. All right, so 0 is equal to v naught, which was 50, minus 10 times t. That's t top. So t top is equal to 5 seconds. That means that the total time that it's in the air is 10 seconds. Let's go back. The total time that the ball is in the air is 2 times t top, which is equal to 2 times 5, or 10 seconds. Then, if you want to know the height, I say y, that gives me the vertical distance, is equal to v naught times t plus 1/2 a t squared. So if I want to know the height, I just put in the time. When it's at the maximum height, put in the time for right here, and then that equation, that parametric equation, will give me that height. So that's going to be 50, that's the initial velocity, times 5 seconds. I don't put time. In fact, you'll see if you put in 10 seconds that you get 0 for the location, because that's where it is at 10 seconds. Minus half of negative, or plus half of negative 10 is minus 5, times 5 squared. That's equal to 250. That's 125, or 130 meters. Okay, so that gives me the position at the top. So that is up here, I have 130 meters. And then I want to know the velocity of the ball at 8 seconds. Or I might ask you the position of the ball at a particular time. But in order to find that, I just say v is equal to v naught plus at. And I just put in that 8 seconds right here. And that gives me 50 minus 10 times 8. That means it's minus 30 meters per second. I'll be looking both for the magnitude and for the direction. Or you could say it's 30 meters per second downward. That makes sense because I know that after 5 seconds, this is 5 seconds. So right here, I know that the velocity of my ball must be negative, is going down. Okay? And then you want to draw the graph too. For the y versus t, it's going to look like that. If it's a v versus t, that graph is going to look like that. I will ask you all 4 of those parts. That's 4 separate questions. And you know exactly what the question is going in. So what I expect is that you know it so well that you just don't even really have to think about it. That you just do it. It takes you about a minute or 2-3 minutes maybe to do those 4 questions, okay? Make sure that everybody gets 100% of those first 8 questions. Can y'all do that? You can. I know you can. Like, you have the math ability. You know what the questions are. We've done a bunch of different problems like that. And you know exactly what they're going to be. 100% on the first 8. Okay? I don't usually say no excuse, but really no excuse for not getting 100% on the first 8. Okay? Y'all can do it. I know that you can. Right? Y'all did so well in that quiz. Y'all can do well on this part of the exam. Okay. Number 2 is a little bit more difficult. Now, we've done this one in class. Why don't we go and do the Fall 19 one, which is a little bit different. Fall 19 and Fall 21 are good examples of what your free response are. So let's go down to Fall 19. I know y'all don't have this in your book, but we've done that one in class. So let's do a slightly different one. This one's a little bit different, but it's the same in that it's a system of two equations with two unknowns. Again, I know that algebra sort of scares some of y'all, and that's okay. You don't have to be unafraid, that's fine. But I know that you know how to solve a system of two equations. You've done it before, so we need to mine it out of the recesses of your mind and remember how to do it, because in chapter 4 it's going to come up again, and I don't want it to be shocking to y'all. So on any kinematics problem, the first thing you want to do is just write down what you know. I know that x is equal to 100 meters. I know that the total time is equal to 10 seconds. And then I got to do some reading and think about what's going on. I know that V naught is not 0 because it's starting out at some speed and then it's slowing down to a stop. So V naught is not 0, but V is equal to 0, right? Because it's starting and then it's stopping. So the final velocity is 0 meters per second. I don't know what the initial velocity is. In fact, that's one of the questions. And I don't know what the acceleration is, but I do know that that acceleration better be negative. Bryce? Yeah, so like this truck is right here, and it's traveling with some velocity, and then it slows down as it goes through on the road, and now down here it has a final velocity equal to 0. Okay, I want to know what this initial velocity is, and I want to know what that rate at which it slows is, what that acceleration is. That acceleration better work out to be what, positive or negative? It better work out to be negative. It will if we do it correctly. But that's a good check for you, that if it comes out positive, he's like, oh, I've done something wrong, and then you can go back. Always step back and look at your problem and say, does this make sense? Do these numbers make sense? Do the signs work out right, or they sort of fit with what I think it should be? I like to write the two equations right next to one another, and it just allows me to see how they fit together better. So I'm going to say V equals V naught plus AT, and I'll put some numbers in just a second. And then X is equal to V naught T plus 1/2 AT squared. All right, so I know some of these things. Like I know this is 0 equals V naught plus A times 10. I'm going to call that 10A. And then this is 100 equals V naught times 10. Let me write that as 10 V naught, just so it's sort of, I don't know, it's much cooler. 10 V naught plus 1/2 A 10 squared, so that's 50A. Did I do that right? I think I did that right? 1/2 of A T squared, yeah, 50. Yeah, that's right. Okay? So now I've written these two equations. Now I want to substitute one into another. This one actually is a little bit easier than the one that we did in the fall 21 because it doesn't really matter which one I sub into the either one. Y'all go back and look at that fall 21 one that we did in class and make sure that you see the differences. But you're following the same mathematical steps where you're substituting one equation into the other. I'm going to solve one of these for one of the variables. This one's easier on the left, so I'll just say that V naught is equal to minus 10A. And then I take this and I plug it in right here for V naught. So I get 100 equals 10 times negative 10A plus 50A. And look, now I have an equation that I can solve. I have 100 equals negative 100 plus 50, that's negative 50A. So A is equal to negative 2 meters per second squared. And remember how I said it should be negative? It is negative. That makes sense to me physically. And then I can take that and plug it right back in here for A, and that gives me my V naught. Minus 10 times negative 2, that's equal to positive 20 meters per second. That's my V naught. This all makes sense to me. If I'm decelerating at 2 meters per second squared, that means for every second, my velocity decreases by 2 meters per second. I'm starting at 20 meters per second, so therefore I must need 10 seconds to stop. Is that what I had? Yeah, I had 10 seconds to stop. So everything seems self-consistent here. Everything seems to make sense. You're going to have to do this problem. I want you to do it over and over and over and over again until you don't have to think about it, but you see the substitution really easily. I know that's sort of a memory game, but that's okay because I want you to see this substitution problem and be able to work it easily. Scare you a little bit? Is that a little bit scary? No, it's fine, right? It's just substitution of two equations. It's like a system of two equations. You do that all the time, right? Okay, maybe not, but if it troubles you, then please spend some time on that. And then you're also going to have a graph question. You'll have some graphing questions in the multiple choice part, just like you're going to have kinematics questions in the multiple choice part, but this is just one that I want to make sure that you have. It's either going to be a velocity versus time, or it's going to be a position versus time. If it's velocity versus time like this, I'm going to ask you to find the acceleration, and I'll probably ask you to find the distance. Remember, to find the acceleration, you take the what of a v versus t graph? That's right, Austin. You find the slope. So at t equal 1.75 seconds, I'm going to draw a little dot right there. I'm going to draw a tangent line. Looks something like that. The slope of this line, let's see, how does it do rise over run? It has a rise of -8. It has a run of 0.5. Notice I did not count the squares. So for part A, it's going to be the acceleration is -8 over 0.5. That's equal to -16 meters per second squared. Now, if it was at a different point, like here, I would get a smaller value and it would be positive. Or if it was up here, it would be 0. I could ask it at different points. And then if I want to know the distance traveled, what do I use to find the distance traveled of a v versus t graph? Area, thank you. So I find the area. Remember, this is a v versus t graph. V times t, that's what you would use to find the area. That has units of distance, right? Meters per second times seconds is meters. So if you forget, just look at the units. Likewise, the slope of that graph would be meters per seconds or over seconds. That's the units of acceleration. On this graph, this one's a little bit different than other ones that we've seen because it's not a linear graph, it's curved, and so finding the slope is a little bit different. I think that the easiest way is to look at an individual square and realize that it has an area of 4 times 0.5. It has an area of 2 meters. And then just count the number of blocks under the graph. So I have 2 there, I have 2 there, 2 there, 2 there. I'm going to count these 2 blocks as 2, like that. You see how this one and this one sort of combine to give you almost a full block. I'm sort of estimating it. And then likewise, I could combine these 2 blocks and say that's 1 full block. And then here, I would say that this is probably about a half a block. So I would say that's 1. So now I have 2, 4, 6, 8, 10, 12. I have 13 meters. There's a bit of an estimation going on there, so I'd probably accept anywhere from 11 up to 15 probably. Show me your work as you go through this. If you just write down a number and it's like 9, no credit at all. But if you show me your work and I see that you're finding the area and you write down 10, I'll probably give you full credit for that. If you just sort of judge the way you added the squares a little bit differently, if it's just a mistake like that, I'm going to give you full credit. Okay? Y'all clear on that? If you don't show any work on this part, no credit. I need to see the work, and I need to see it fairly clearly and be able to understand what you've done. That's good for you. That means that whereas in a multiple choice question, you just get it wrong if you get the answer wrong, in this one at least, if you made some small mistakes, you can at least get half credit. But you're not even going to get half credit, are you? What are you going to get? 100%, everything on those first 8 questions. And then I find that students, when they do really well in that first part, they go into the multiple choice just feeling really confident, and they're like, I got this, because they've done so well in the first part. Don't you, like on a test, when you start doing really well in the first part, like that bodes well for the rest of the exam? Well, that's right? So if you do really well in this part, it does bode well for the rest of the exam. So spend a lot of time focusing on this free response. Graphing. You want to get graphing? Everybody, right? I think when you say graphing, you mean the qualitative graphs. Because when I look at graphing, I think qualitative graphs, that is, you look at things not really numerically, and then quantitative, which is like the one that we just did. So let's look at some of those qualitative graphs. This is the, well, let's go back to the 2021, because many of you have that in your workbook. I don't think we've done these, have we? No. All right, number 20. Remember I told you you're going to have to do this, probably more than once, where you take a V versus T graph or a position versus time graph, and you translate it into something else. This is fall 21? Isn't this fall 20?
That's fall 22.
Oh,
That's fall 20.
That's fall 20. Okay, I'm sorry. We'll come back to 14. Okay. Number 15 is really similar to that question. So number 15, I have this V versus T graph. I want to translate it into a Y versus T. The V versus T, the value right here corresponds to the value of the slope right here. I'm not saying the answer is A. But right here I have this tells me that I have a small positive slope. And up here, I have a big positive slope. So which of these graphs starts out with a small positive slope and then ends with a big positive slope? Don't tell me the answer. But let's look at C. C starts out with a small slope, but it's what? Positive or negative? It has a negative slope. It has a small slope, but it's negative. And then it gets bigger, but it's still a negative. What is the answer? Which starts out with a small positive slope and then gets to a big positive slope? A is right. A is right. See, it has a small positive slope, big positive slope. Let's practice drawing the V versus T graph, say, for B. What would the V versus T graph look like for this? Well, it starts out with a big negative slope. That means that the velocity is going to be big, but in the negative quadrant. That means the velocity is going to be right here. See how it's big but negative? And then it gets small but still negative. So for B, that graph is going to look like that. For C, this is B. For C, small and what? It's small and negative, and it gets bigger and negative. And then that was C, and then D, oh, my pen. It's what right here, small or big? Big, positive, small, positive. So it starts here and goes down like that. Okay, let's look at some other qualitative graphing problems. I like number 13. You're going to have one like this where I describe to you some physical scenario and ask you to plot it, or ask you to pick the plot. This is an object going up and then coming down. I think in the free response I had you draw the position versus time, but here I want you to tell me what is the velocity versus time. Well, it starts out with a big positive velocity right here. It has a zero velocity here and a big negative velocity. The only one that does that is A. Here's the first part, here's the middle, and this is the third at the end. Okay? Gonna see something like that where I describe to you some physical scenario. A car is driving along and it slows down. What is the position versus time graph? Well, let's think about that. If I have a car that is driving along with some velocity, and I want to know the x versus t graph, say it has a positive velocity, or I would say it's traveling to the right. That's a positive velocity, and it slows down. What would that look like? Well, it would have a big positive velocity to start. That's going to look like, how is that going to look actually? Big positive. It's going to look like this. And then that slope is going to get gradually smaller. So that graph, where a car is moving to the right, and slowing down would look like that. Does that make a lick of sense to you? Yeah? Okay. Let's look at some of these others that are qualitative. You have I mean, look at, there's like 5 questions like this on this test. It's important. Um, Number 14. These are probably the hardest questions on the whole test, where I give you some graph and I ask you all these different statements. Are they true or false? But this is just a good way to prepare for standardized tests, because standardized tests like that, where they give you statements. You have to say, is this true or not? And sometimes it's just a single word that makes it true or untrue. So, read them carefully, read every single word, and know that every single word is important. I have this velocity versus time graph. I want to know which of these statements is true. The object has a negative acceleration at point A. Let's come back to that, okay? The object has an increasing speed at point C. All right, well, look, it had a 0 speed right here, and then oh, wait, no, I'm sorry. This is a velocity versus time. Let's go back to number 1. The object has a negative acceleration at point A. Is it speeding up or slowing down at point A? It's speeding up, right? I'm just not looking at the slope. I'm just looking at the numbers, because it's going from here to here at point A. It's going from 1 to 2 meters per second. So it's speeding up. And is that a positive or a negative velocity? Positive, right? Because it's in the first quadrant. So is the acceleration positive or negative? It's speeding up with a positive velocity. That's right, Austin. The object has a positive acceleration, so that statement is not true. So there's a lot of gymnastics going on in your head with that, even just that first statement. That's why I say these questions are so hard. The object has an increasing speed at point C. True or not true? At point C, it's going from here down to here. No, it's actually slowing down, so it has a decreasing speed. The object has 0 acceleration at point B. Is that true? Why is it true? It's at the top, but what is it about that graph at that point that makes the acceleration 0? No, not the velocity. I mean, the velocity is 8 right there. What is it about that function at point? No, not the distance, no. The slope. That's great, Dennis. Yeah, so the slope of that function at that point of that tangent line is 0. That means that it has a 0 acceleration. So 3 is right. Let's just look at our options. So I know it's not 1 and 2. I know it's not 1, 3, and 4, because I've already discounted 1, right? I know it's not 1 only. So it's either 3 and 4 or 4 and 5. Well, it has to be D, right? It has to be 3 and 4. Let's just double check that. The object is traveling its fastest at point B. Is that true? It is true, because it's traveling 8 meters per second. Remember, this is a velocity versus time graph. So the answer is 3 and 4. We go to look at 5 too. The object is traveling in the same directions at points D and E. Point D is Sorry. At point D, the velocity is positive 2. At point E, it's negative 0.5. So notice they've changed directions. When it crosses over that axis, it changes direction from the positive to the negative direction. That's probably the hardest question on the test. There's so much stuff packed into that question, and you have to look at each of them to get it right. 3 and 4 is the right answer. Okay? Y'all can do that too, right? Read them carefully. Every word is important on these tests. Sorry, is that scary? Is that scary a little bit? No. Good. Good. No need to be scared. All right. Here is another kinematics. Can we do another kinematics question? You're going to have 2 or 3 of these in the multiple choice part 2. They're not going to involve a system of 2 equations, but it might be a multi-step problem where you have to solve one part of the question in order to get to actually what you want. So here, start it the same way. I write down what I know. V0 is equal to 40. It slows down at a rate of 20. That means that the acceleration is going to be opposite the velocity is positive, so the acceleration is negative. And I want to know x. I know that x is equal to v naught times t plus 1/2 a t squared, but I don't know t, all right? And I don't know x. So I have to figure out t. But I can figure out t. I say that v is equal to v naught plus at. Oh, I forgot. Here, it comes to a stop. That means that v final is equal to 0. Not v initial, but v final. So that's going to be 0 equals 40 minus 20 times t, so t equals 2 seconds. If you ever get a negative time, make sure you go back and check the problem. You've made a mistake. You should never get a negative time. Now I can find my x. That's going to be v naught, which is 40 times 2 minus 10 times 2 squared. That's 80 minus 40, that's 40. Okay? C is the right answer. You're going to have 1 or 2 questions. I think you have 2 kinematics questions. Look, usually these exams have these vector questions on them. Like here, you're not going to see these questions on this exam at all. Usually it's got 3 or 4 questions that have to do with vectors, not on your exam. But that means that you get a couple of extras in graphene and kinematics. We get to, play around with those things a little bit more in some of the questions. But otherwise, the exams will look a lot like this. Okay? What else would y'all like to look at? Any particular questions on particular exams or just particular topics that you want to see? Okay, the quantitative you mean? Like where I'm crunching numbers or where I'm just looking at, you want to do more of the graphs like the quality?
Yeah.
Okay, more of those. Okay, well let's go down to other exams. That's the great thing about this class is you have so much opportunity for practice. You have lots of opportunity for practice. So, and it's going to really help you with the exam. It really will. The more you practice, the better you'll do. Oh, here's another one, like that one that was so hard before. Look, there was a similar one on this exam. This was the fall 20 exam. This, though, is not velocity versus time. Notice this is position versus time. So I'm going to approach this a little bit differently. If I'm looking at velocities, I'm going to think about the slope of this graph. It'll be a little bit different. The object is increasing speed between B and C. Well, notice that the slope at B is 0. So that thing is not moving at point B. But at C, it has a bigger positive velocity. Did it increase its speed? Sure. It went from 0 to something not 0. So that one's correct. Ooh, by the way, I can go down and I can start marking off things. I can mark off B. That's a great practice for your standardized tests, you pre-meds, pre-dents, etc., etc. Like marking off answers that don't make sense is a great way to do better on those exams. The object has a positive velocity at E. Is that a true statement at point E? No. Why is it not true? It has a negative slope, right. So that's not right. So anything with 2 in it I can get rid of. The object is at rest at C and at D. No, because at C it's moving. You could say at D, yeah, it's at rest. It has 0 velocity, but not at point C. So that's not right. I can get rid of that and that. Look, now I have the answer. It's 1 and 4. Let's just check 4. And 4 was the hardest statement to figure out. Well, let's figure it out. Between point C and D, the object has a negative acceleration. Between this point and this point, is it speeding up or slowing down? Slowing. Is it positive or negative velocity? Positive velocity, right? Because this is a positive slope, but it's getting to be a smaller slope as I go up. Slowing down means my acceleration is opposite the direction of the acceleration. So those two together tells me that I have a negative acceleration. But I already knew that just because I eliminated all the options except for A. You'll have a question like that. Pretty similar. I mean, not the same. They'll have different statements, but they'll be in the same strain of that. Yeah. 16. Yeah. There was a similar one in the fall 21. The speed of the rock is the same at points B and D. True? Yeah, true. Think about your hand. If I throw it up and it comes back down, the speed here is the same going up as down. Now, if I said the velocity is the same, not the same. One's positive and one's negative. But the magnitude of the velocity or the speed is the same. That one's okay. I can get rid of all three of those. Like now it's either, all I have to get is one negative answer and I have it. The speed of the rock is the same at points A and E. Is that true? Yeah, that's basically the same as 1. The time for the rock to travel from A to B is the same as the time to go from B to C. Ooh. So the time to go from here to here is the same as the time to go from here to here. No, that's not right. So 3 isn't right, so therefore it has to be A. It goes faster in the beginning, right? It goes faster initially, so it takes less time to go from A to B than it does from B to C because it's slowed down when it gets up to that top part. So the time to go in those top regions is slower than it is in the bottom regions, just because it's decelerated or slowed down up at those top points. And then the acceleration at the top of the trajectory is 0. We know that's not true. We talked about that today. The acceleration at the top is equal to minus 10. And we can tell that if we plot the y versus t, it looks like that. The slope of that graph is always negative 10. Even right here, where it's at the top of the trajectory, that slope is still negative 10. Okay? I'm sorry, I said y. This should be v versus t. Sorry, I'll fix that. Really, the y versus t looks like this. An inverted parabola. Those are tough, y'all. The graphing parts are probably the hardest part. Listen, don't do this question, okay? It was not right. I did not do it. Other particular questions? You do the, how does the y versus t look for this? Big negative slope to start, small negative slope to end. Which one is that? What's that? B, right. So B starts out with a big negative slope, small negative slope. See, big negative slope is like minus 5 or whatever. Small negative slope, minus 1. My slope is minus 1. My slope here is minus 5. My slope here is minus 1. The value in the v versus t translates to the size of the slope, or the magnitude of the slope in the y versus t, or position versus time. You're going to have some like this, quantitative graphs, like we did those. So here, if I want to know the distance that is traveled at 3 seconds, I draw a line right here, that's at 3 seconds, and I want to know then the distance that it travels up to that point. That would just be the area of that graph up to that point. Notice I don't include the other part. To find that area, I say the length of the base times the height, which is 1 times 4, so I have 4 units there. And here it's going to be 1/2 base times height. That's 1/2 of 2 times 4. That's equal to 4 units as well. Okay? So that's going to give me 8 meters as the answer. All right? Particular questions. I think we've hit all the major categories of questions. Remember, if you get anything that says vectors, no vectors. I think all those questions will have the word vector in them. Anything from chapter 1, dimensional analysis? It's all good on that? Really? Okay. Sig figs, trig, you have 2 trig questions. I'm good for another 10 or 15 minutes. Conversion factors. Okay, so look, you're going to have a problem that's a lot like number 9. Okay, I'm not saying you're going to have number 9, but it'll be a lot like that. It's going to involve a converting from British to metric units, and also converting from like a non-squared or non-cubed to a cubed or squared. So probably in this case, the easiest way to do that is to convert your inches into millimeters and then calculate this, in this case, the volume. But it might be area, it might be acceleration or something like that, where you have a squared or cubed in the units. But let's do this one. I say I want to first convert my 0.5 inches to millimeters. In high school, you probably set up something like this. Is this the way y'all did it in high school? Yeah, if you want to do it that way, that's fine. I'll do it that way here. 0.5 inches, I have 12 inches here. The inches cancel there, and 1 foot here. And then my next conversion factor is 3.28 feet and 1 meter here. So my feet cancel there. And then 1 meter is equal to 1,000 millimeters. You need to know that conversion factor. Or, if you don't want to think about it in that way, that's the way I tend to think about it. You could say 1 millimeter is equal to 10 to the minus 3 meters. That's technically the way we learn the metric prefixes, right? That a millimeter is 10 to the minus 3. Let's say a millimeter is 10 to the minus 3 meters. So that's really holding in key with what we found. And then this is equal to whatever it is. I don't know what it is. But then we want to convert that value to cubic, or calculate the volume. And then to calculate the volume, well, I just say volume is length times width times height. And then I multiply this number times itself twice, I cube it, and then that gives me the volume. Whatever number I find here, when I do all these operations, when I multiply or divide all those out. Notice, always go back and check your units that they cancel out properly. Feet, 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 meters, meters. So I'm left with millimeters. Okay. I think I had another one like that here. Oh, how many millimeters are in a kilometer? Well, you know, there are 1,000 millimeters in a meter and 1,000 meters in a kilometer. So it'd be 1,000 times 1,000. So that's 10 to the 6. C would be the right answer. Y'all look really excited about this exam. You really do. I'm pumped for it. I'm ready. Y'all look ready too. Are you ready? Yeah, you're excited about it, right? Not just ready, but you're excited about the awesome opportunity to show me what you've learned and get this first exam under our belt. I will say, let me let y'all go after this, but I will say that I have a bunch of meetings on Wednesday afternoon and Thursday and even Friday. And usually I like to get the exams back the next day on Friday and even the grades back same day. But your grades are probably not going to be ready until like Tuesday of next week. And I'm really sorry. I'll try to get it done before the weekend, but I'm just not sure that it's going to happen. And I just apologize in advance, okay? It was not something I could prevent. Okay? I think that's all. Y'all have a great day.